Stuck, literally turned my car off, stuck in traffic coming back from Dallas yesterday. It's horrible. All right, so you guys have, well, there is an opener. We talked about this, I'm going to say yesterday, last week. And there's 3 different types of solutions. There are unsaturated, there's saturated, and there's supersaturated. What's the difference between these 3 types of solutions? Let's just take like sugar water. What would be the difference between the 3 types of solutions for sugar water? Okay, what does unsaturated mean? What's the prefix un mean? What does un mean? Not. Okay, so unsaturated means what? It's not saturated. That means that you can still put more sugar into the water and it will dissolve. That is what unsaturated means. What does saturated mean? It says 46. It says 46 on it. What is saturated? If unsaturated means that it's not, like there's more that can go in, what does saturated mean?
No more.
Yeah, no more can go in, it's full. Okay, now, so what's the difference then between saturated and supersaturated? Has more than what should. Okay, and the way that we do get something supersaturated is by stirring, is by heat. Also by, you can crush things up and it'll go into solution faster, but what forces you to have more than what it wants specifically is the stirring and the heat element. We are going to analyze these, and I realized when I printed this off on the backhand side that it didn't give you the letters, so they're actually on like my screen. Unsaturated means more of the solid can go in. It's not full yet. Saturated means it's completely full. There's nothing, like when you make Kool-Aid with too much sugar, you know how you get the goopy stuff at the bottom? That's super saturated. Saturated means that you cannot put any more sugar into it in the case of sugar water. All right, we have a solubility curve. The way that this thing is read is on the left-hand side, this is how many grams of the solute, that is the solid, can go into 100 grams of the liquid, which is the solvent. Super means that you have more of the solute, the solid in the solution. Okay, and then we have temperature up to 100 degrees Celsius going from left to right on the bottom. And I have all these different compounds. I've got sodium nitrate, potassium nitrate, hydrochloric acid, ammonia, ammonium chloride, potassium chloride, sodium, all these different things on here, and they all have their own curve. Now, some of these, as we go from left to right, they actually increase solubility with temperature. And some of them, as we go left to right, they decrease the solubility as you increase the temperature. That's one of the last questions that we're going to go over on this. First one says, what is the solubility of potassium nitrate at 30 degrees Celsius? Okay, so I know I'm going to be on this line right here, which they can't see me pointing. So here's 30 degrees Celsius, and I need to find potassium nitrate, which is up here. This is potassium nitrate. So I'm only going to be looking at this line, and I need to figure out where 30 intersects it, which is right about here. So now I put potassium nitrate, no, 40, I put 47 down is mine. Now, honestly, where you read the intersection here, if you said, because it's out between 40 and 50, if you said 46, I'm not going to count it wrong. That's sort of a judgment, but you're looking only at the specific line for that compound. So you need to know what your formulas are still. That, like I said, that doesn't go away. That was from the beginning of the semester. So once again, at 30 degrees, for those of you that are, a few that are remote, so at 30 degrees, we are looking at the intersection of this potassium nitrate, which is about here. I said it was 47 grams. The second one, how many grams of ammonia can I dissolve in 200 grams of water at a temperature at 45 degrees Celsius? So here's ammonia. Okay, and I'm going to go to 45 degrees. So that's about here. Okay, so this is, now keep in mind, this is for 100 grams, but the question's asking you for how much? 200. So instead of 32 times 2 would be what? 64. Okay, so that's honestly, that's the trickiest they can get. I mean, pulling numbers off of a graph should not be that hard, but this is per 100 grams of liquid. If it asks, like in the next case, well, number 4, 300 grams, you would multiply wherever the curve is times 3. All right, for number 3, at what temperature is the solubility of sodium chloride the same as the solubility of potassium chloride? So I've got salt, here's potassium chloride, here's sodium chloride. Here's sodium chloride. So that's this one. And it's going to intersect right here. So at what temperature, no, I got it wrong. Potassium chloride, sodium chloride, right here. So this would be at what? Yeah, I'm gonna say it's like right at 35, as long as my potassium chloride, sodium chloride, yeah, 35. I put down the wrong number on here. And this is all degrees Celsius, it's not Fahrenheit. How many grams of sodium chloride would I need to make 300? So whatever this graph is going to read, we need to multiply by 3. So ammonium chloride at 70 degrees. So just above 60, so we'll do 61. But it's for 300 grams, so you need to multiply it by 3. So if it is 61, it would be 183 grams. Now we're getting more into the terms that, like, for the opener. 40 grams of potassium chlorate were dissolved in 100 grams, great, so 100 grams of water at 50 degrees Celsius. Here it is, 50 degrees. Back to this. No, I lost where I was at. 40 grams of KCl3 resolved at 50 degrees Celsius. So potassium chlorate at 50 degrees. So I am looking at, okay, to be saturated, it's just over 20. How much do you have in your problem now for number 5? You have 40. So if essentially 20 is saturated, but you have 40, do you have under, right at, or over the amount you're supposed to have? So that's super saturated. This is saturation, just is how much of the solid is present in your liquid. Normally solid in the liquid. There are like others, there's gases and gases. What do the compounds that have decreased solubility over temperature in the graph have in common? Okay, some of these go down left to right, and some of them go up. The ones that go down, ammonia, hydrochloric acid, sulfur dioxide. What type of compounds are those? Are they ionic or covalent? They're covalent. They're covalent. SO2, NH3, HCO, they're all nonmetals. So all of the ones that are going up are going to start with a nonmetal. So we've got potassium, sodium, potassium. This is an ionic compound. Potassium, sodium, those are all ionic compounds. Ionic compounds tend to become more soluble as you increase temperature. Covalents do the opposite. Or molecular, it's the same thing. Like I said, I haven't seen the test. I have no idea how they're going to work stuff. So compounds that have decreased in solubility with temperature increase are going to be covalent or molecular. Which compound is the least soluble at 40 degrees Celsius? What's the lowest curve at 40? Which compound is the furthest down at 40 degrees? SO2. That is a covalent compound. And then it says, which ionic compound is the least soluble at 40? So the next one up, KClO3, the potassium chromate. Or, no, potassium chlorate. Like I said, I have not seen your CBA. I do not know how evil it is. I do know that there is a heck of a lot of math, like mass conversion kind of math. And I just put together a review for you, not knowing exactly what's on the test, but I know that there are limiting reagents. I know that there are percent yields, and it's like heavy math. It's not like one-step easy stuff. You guys did not get the letters transferred over onto yours. The first diagonal left should be an A. First flat should be a B. Next diagonal up should be a C, next flat should be a D, and then the last diagonal up should be an E. Text message from, what the heck is that? Oh, I got food delivered. Yay, and there's nobody there to pick it up. Joy. All right, so which letter represents, okay, let's make sure you understand what a phase diagram does first. Further to the left is colder. Further to the right is hotter. Okay, this is the easiest to do with just the states of water. Okay, so what would A be? Yeah, it would be frozen. That would be ice. In the case, I'm not answering the questions quite yet. What would be happening at letter B to the ice? It would be in the process of melting, but not increasing temperature. C would be liquid, would be increasing temperature. So what would D be? Boiling or evaporating. Just depends if you add heat. And then E would be steam or water vapor. Okay, so now the questions, it says, what letter represents the freezing point of this substance? Freezing point. Which letter is freezing point? No. It's already frozen at A. B. B is the go-between between the solid and the liquid state, which would either be freezing or going the other direction would be melting. Okay, which of these then represents the boiling point of this substance? D. C would be the liquid state, E would be the gaseous state. In letter D, step D, position D, whatever you want to call it, you're actually breaking the molecular bonds from the liquid to the gaseous state, but there's no increase in temperature. Which letter represents the range where a solid is being warmed? That's a liquid. A. Solid, melting, liquid, boiling, gas. The diagonal up ones, they're increasing in temperature. The flat ones, they're not changing temperature. All that energy that you're using to try to heat it up, it's not heating it up, is breaking the bonds to make them be able to move easier. Which letter represents where the gas is being warmed? E. And then where the liquid's being warmed? C. Flat on a phase diagram, which is what this is. Flat lines are state of matter changes. Diagonal lines up would be heating, going the other direction would be cooling. What is the value for the freezing point? Each of these is worth 5. So here's the freezing point. What's the freezing point of the substance? Each jump is worth 5. 55 degrees Celsius, which is hot. Really, really hot. I don't know what this substance is. The boiling point would be here, and it's right on what? 90. Once again, this is Celsius, not Fahrenheit. So the melting point is also there. Condensation is the same as boiling. So it's going to be the same 55 and 90 degrees for number 7. Does temperature change during a melting or boiling process? Oh, no, for water, if you're talking about Fahrenheit, it's 32 degrees. Until it's completely frozen or melted, it's not going to change. And for in Fahrenheit, boiling is 212 degrees. Until it's all steam or it's all been changed. Like I said, I don't know what is specifically on the CDA. What I do have now, the actual assignment for today, is the Google slide that you guys have over solutions. Like I said, your notes, they're technically due tomorrow. I did not put solubility stuff on it. I didn't. It's mostly the math, limiting reagent, and I've got mass on. That you're going to have on your CDA. I don't know what's on it yet. So y'all have this. There's a link to this in Canvas. I can load it correctly. Solutions Google slide assignment. You know what? I need to actually assign it points. That would be wise since it's a grade. Let's fix that. Save. All right, so in here, you guys have access to the slides, just like normal. If I take it off of here, you can drag and move. This is more what we did Friday. If I say yesterday, I mean Friday. Remember the solute is the normally solid. It's the thing that is dissolved. The solvent is the stuff that does the dissolving. All of this is just vocabulary from Friday, if you need to pull that out. But this is the actual assignment for today. I need to check and see if anybody's turning their notebook. I saw as you guys were starting to put some stuff in, but I didn't have the time to actually grade them. So I'll go in and look. Guys, if I took attendance, you'll see Aiden, Declan. Okay, so no, Delvin, Bailey, Veronica, Lucas, Tatiana, Reagan, Slate, Braden, and Alexis. Let me stop the recording here.